This lesson reviews defining a sequence recursively. In order to define a sequence recursively, you need to give two pieces of information. The first one is the starting term. Where do you start? And the second piece of information is a rule to find each subsequent term. That means a rule to allow you to find any term by looking at the one that comes right before it. Subsequent means the term that comes next, so you give the first term and then a rule to find the next term. Here's an example. This example starts with the definition of the sequence and then looks at the list. The first thing I want you to notice is that I'm giving you the definition of the sequence in words. I'm telling you where to start and where to go. So let's translate that into symbols. So first of all, how would you say start at 7 in symbols? Well, we need to say that the first term is 7. So that's how we put that in symbols. U1 equals 7 means the first term is 7. Now, here's the rule. To get the next term, add 8. How do you put that into symbols? Well, this one requires a little bit more notation. So U sub n equals U sub n minus 1 plus 8. That means to get any term, let's call it term n, look backwards at the term that came right before it, which would be n minus 1, and add 8. Okay, from that we should be able to write a list. So I'm going to write the first, let's say 6 terms of the sequence. Alright, well, where do I start? I start at 7. What do? I add 8. 7 plus 8 is 15. 15 plus 8 is 23. 23 plus 8 is 31. 31 plus 8 is 39. 39 plus 8 is 47. And you could keep going as far as you wanted. I'll just put 3 dots, which means, and so on. Alright, so hopefully that makes sense because I now have a homework problem for you to do that is quite similar. So for the first homework problem, I've given you the definition in words. Told you in words what the first term is and what the rule is to get each subsequent term. What I'd like you to do is copy the chart and then translate the words to symbols. How would you express or define this sequence with symbols, just like the previous example? Once you've done that, please go ahead and list the first 6 terms of the sequence and then identify it as arithmetic or geometric. Okay, if you need more time copying that, please pause the video now because I'm going to the next screen. Okay, this next example goes in the reverse direction. I'm going to start with a list of numbers and try to generate a definition from that. So the first thing to realize is that this one is not arithmetic because 75 to 15, well, you could say how much did we go down? 75 minus 15. So it went down 60. From 75 to 15 was down 60, and then it didn't go down 60 to get to the 3. So this one's not arithmetic, so we'll check in a minute, see if it's geometric. But I do know the starting term, right? The starting term is, oops, let me put it on the marker. The starting term is clearly 75. Okay, and then the way we would express that with symbols is say U1 equals 75. Okay, now the rule. Well, it's not about adding or subtracting a certain amount, so perhaps it's geometric. So in order to check that, we would just try 15 divided by 75. If you do that, and you can check me, you'll get 0.2. Well, that's not enough to be sure that it's geometric. That was the second term divided by the first term, which essentially means if you take 75 and you multiply it by 0.2, you'll get 15. Okay, let's see if that ratio holds. So now I'm going to take the third term and divide it by the second. If you do 3 divided by 15, you will also get 0.2. Again, that means 15 times 0.2 is 3. You can check the others if you want. 0.6 divided by 3 will also be 0.2. 0.12 divided by 0.6, 0.2, and so on. Or you could just start at 75, multiply by 0.2, and again, and you would see that you get the numbers listed here. Alright, so the rule is multiply, should write that in words, but I'm saving some time, multiply by 0.2. So to write that symbolically, to find the nth term, you want to take the term that came right before it and multiply it by 0.2. Typically we put a coefficient in front. So there it is recursively. Okay, so the next page has your second homework problem. So I want you to consider this sequence, 180 and so on. Copy it down and then come up with a recursive definition. First give that definition in words and then in symbols. And lastly, identify it as arithmetic or geometric. Okay, again, this is the time to pause the video if you need to copy down this problem because the video is about to end.